Imagine a world where we don't just rely on the sun, but create our own. A miniature star, born in a lab, fueling our cities, powering entire civilizations, and pushing humanity beyond its limits. Sounds like science fiction? Think again. Scientists across the globe are racing to create the ultimate energy source, a lab-grown sun. But how close are we? And what could it mean for our future? Let's find out. The idea of a lab-grown sun isn't about creating a literal star that hangs in the sky, but rather, replicating the process that powers the sun. Nuclear fusion. Unlike the nuclear fission, which splits atoms and creates hazardous waste, fusion smashes atoms together, releasing immense energy, clean, limitless, and incredibly powerful. The sun achieves fusion naturally, thanks to its gigantic size and gravity, which squeeze hydrogen atoms together at 15 million degrees Celsius. But here on Earth, we have to get even more creative, because we don't have the sun's gravity to help us out. The dream of harnessing fusion power goes way back. In the 1950s, Soviet scientists introduced the tokamak, a donut-shaped machine that could trap superheated plasma in a magnetic field. Since then, research has exploded across the world. China's East reactor recently broke records by sustaining plasma at 70 million degrees Celsius for over 17 minutes. That's 5 times hotter than the sun. Meanwhile, the International Thermonuclear Experimental Reactor, ITER, in France is the biggest fusion project in human history, aiming to produce more power than it consumes. A holy grail for fusion science. But here's the challenge: fusion isn't easy. Containing plasma at temperatures hotter than the sun requires magnetic cages stronger than anything we've ever built. One of the biggest challenges is plasma instability. The superheated matter can behave unpredictably, making it incredibly difficult to maintain controlled reactions. Additionally, current fusion reactors consume more power than they generate, making them inefficient. The extreme conditions also place immense stress on reactor materials, leading to rapid degradation and high maintenance costs. And, of course, funding is always a challenge, with projects costing billions and requiring decades of investment. Yet, the breakthroughs keep coming. Scientists are experimenting with lasers, superconductors, and even quantum physics to push fusion closer to reality. Companies like Helion and Commonwealth Fusion Systems claim they could achieve practical fusion energy within this decade. Could we finally be on the brink of success? If we master the art of creating artificial suns, the consequences will be game-changing. Imagine unlimited clean energy, no fossil fuels, no nuclear waste, no reliance on unpredictable renewables. It could power entire cities, desalinate oceans, and even revolutionize space travel, allowing humanity to settle on Mars and beyond. And here's a wild thought: what if we could build a star-like reactor in space? A floating power station that beams down unlimited energy to Earth. Sounds like something out of Star Trek, right? But with the way technology is advancing, it might just be a matter of time. The race for a lab-grown sun is more than just science, it's a mission to redefine the future of humanity. The dream is massive, the challenges are enormous, but so is the potential. So, will we live to see the day artificial suns power our world? The answer lies in the hands of the brilliant minds working on fusion as we speak. When do you think fusion will become reality? Let us know in the comments below. Like and subscribe for more cutting-edge science content.